Hey folks, how you guys doing? Hope you're all having a great day today. This is video 3 in my CNC video series about this particular machine. So I'm not actually making any projects in this series, although I have been putting this thing to use throughout, building it out. But this particular series is dedicated to the machine, the setup, everything that I'm doing to modify it, and why. So that I have a place to point people to when questions start coming in the future as to how I did something or why I did something. So video 1 was building the machine, why I chose what I chose. Video 2 was on the dust boot for the spindle, the dual 4-inch dust boot for the spindle, which works really, really well, I might add. Video 3, this video is going to cover the spoil board or the horizontal table as well as the vertical table, which is very interesting. And if you think anything in this video is interesting, be sure to subscribe. Go to my website, jcustomcreations.com/newsletter, and sign up for my email newsletter so you don't miss anything that I publish, because the next video, video 4, is going to cover my machine file, which is basically everything you see here, but on the computer, and why that file, that template file that I have created with every bit of engineering involved with this, and why it's so valuable. So I think if you are interested in this video, you'll definitely be interested in the next video. The work on the horizontal table starts by prepping for the T-track by drilling a bunch of holes through the first layer of MDF that I added back in video 1. Now, drilling holes for the T-track, that's because this particular T-track is quick track. It's actually quick track from Armor Tool, and it's taller T-track. It's about 3/4 of an inch tall, and it has 2 tracks, one on top, one on bottom. The one on bottom is very handy because you can put bolts in the bottom track and actually bolt it to the work surface rather than relying on tiny screws that a lot of single layer T-track is installed with. Tiny screws screwing into MDF doesn't really allow a lot of heavy duty clamping applications, right? So you're limited to light duty clamping before you actually use the clamp to pull the T-track right out of the surface that it was secured to. So having bolts bolted to allowing this to bolt down to the first layer, that's going to greatly increase the strength and basically lock the T-track in place. I'll never have to worry about this stuff pulling up, which is another step towards bulletproofing this design. So with the holes mounted, we went through the process of installing all of the bolts, and then all of the T-track can be installed onto the first layer and then bolted on from below, or the nut and washer is installed from below. At this point, all of the T-track is installed, but it is a full 3/4 of an inch above the top surface of the first layer of MDF. So as you'll see, this is kind of stacking a few layers of MDF, and I am losing a little bit of vertical cutting capacity, but I don't think that'll ever be a situation. As it sits right now, completed, I still have like 6 3/4 of an inch from the top of the spoil board, which has, again, 3/4 of an inch to go all the way through it before I have to replace it, to the bottom side of the gantry. So I still have a lot of vertical space, and I've never maxed out the vertical space. Actually, I did one time on my last CNC machine, which had less than this, so I just don't think it's a huge concern. After the T-track is installed, we filled the space between the tracks with 2 layers of MDF. And this was done by cutting a bunch of MDF into strips. Actually, 2 full sheets of MDF we broke down and cut it into a bunch of strips. And not all of these were the same size, because I had to kind of position the track around the frame below. There are several of them that do have I think 4 3/4 of an inch spacing in between, but I think it's only about half of them. The rest of them are just oddball sizes, basically due to not hitting the frame down below the spoil board. Now that's actually beneficial in some cases, because if you have a standard distance in between every one of the tracks, well then you're locked to that amount of capacity for clamping, right? So if something just doesn't line up because the track is just a smidgen too far from one another, in this case I can slide it or move it to another place, hopefully, to have a couple pieces of track that are closer together. So it is beneficial in some cases to have an irregular spacing of the track. After all the pieces were cut and sitting in place, I started to glue 2 rows at a time. So I spread around a bunch of glue with a paint roller and then set them in place, make sure everything lined up on the ends, and then use the track in between with some ash hardwood strips with a hole drilled in the middle of them to clamp down 2 rows at a time. And this worked out really well, but it was a lot of hurry up and wait work because I only wanted to cut up a few strips of ash to do just a few at a time, and also I didn't have enough bolts at the time as well. So I had to, over the weekend, come in, clamp down a couple, and then go do something else, come back in, clamp down a couple more, go do something else, back and forth, and it took basically the entire day of just casually coming into the shop to get a little bit done, to clamp everything down and get it all glued in place. So with the entire spoil board glued down, I can come back and actually flatten it for the first time. So to do this, I'm using a Whiteside 6220 spoil board bit, flattening bit, fly cutter, whatever you want to call it. It's a big surfacing bit, 2-inch diameter, and this one is coated in an Astra coating from Bits, which is a perfect opportunity to mention that I've been working with Bits, doing a little bit of advertising work, and if you're interested in some quality router bits for both CNC as well as handheld router table type stuff, go to bitsbits.com, use the promo code JBates15, and you'll save yourself 15%. But this bit allowed me to surface the entire spoil board, taking out, I think I had set it to about 0.05 inches, and in some cases it looked just like 0.05 inches, not much at all. But in other cases it was up closer to 1/10 of an inch. It was taking a kind of a big bite in some spots, and that just goes to show you the irregularity of MDF. You look at it and it looks like a big composite sheet that is manufactured to a really good thickness or whatever, but there's some variables that come into play if it swells up from moisture around the environment in which it's stored, or in this case I used glue to glue 2 layers down so that different thicknesses in the glue. Basically, flattening it like this is what you always do with a CNC machine because it creates a plane on the surface that is exactly parallel or coplanar to the movement of the machine, which is exactly what you want to have the most precise cuts. You never want to just put a spoil board up there and then mount stuff to it and start cutting. Although you can do that, you're not going to get as precise results if you don't flatten the spoil board. With the spoil board flattened, a 1/2-inch 2-flute upcut spiral bit is added to the machine to cut all of the dog holes. Now, these particular dog holes are sized for 20mm dogs, which is very common for, say, Festool use. Festool pretty much made the 20mm dog very, very popular, 20mm dog hole. And in this case, I'm using a bunch of holes to set up a grid on the wasteboard that is basically a bunch of corners. So let me bring the camera in closer and I'll give a little bit of demonstration as to why this is so convenient. On my last CNC machine, I took a 30-degree pencil point V-bit and I scratched a grid starting at the physical 0, of the machine and a grid of 2-inch increments in both X and Y. And that gave me an instant visual representation of where to place stuff based upon where I designed it on the computer space and digital space. So for example, my X value was really close to the edge of my spoil board, and I know if I put something on that particular edge, way over here on the left side of the screen, I don't have much clamping force or clamping capacity on the side. I can't really get a clamp over here. So in my last machine, I knew that I needed to go to X value of 4 before I clamp down on the side if that's the method I wanted to clamp, and if it fit inside the rest of the cutting envelope. So it was very handy to, for instance, start my origin on the software at a physical location of X4, Y6, and then have that grid located on the spoil board. I could instantly place my material, line it up with those grid marks so I know that I'm perfectly in line with those axes for casual clamping down of stuff that did not require a very precise exact location, right? So that was very, very handy. I also used 1/4-inch steel dowels or steel pins to put into the wasteboard to act as a physical stop for repeat locating and then lateral clamping. And that was very nice, very convenient, but the problem I ran into with that is the 1/4-inch steel dowels, all that pressure is put in a very small location, so that pressure is not dispersed amongst a wider area. So instead of 1/4-inch, I also want to continue that same trend here, or that same concept here, but in this case with larger dowels. So these are TSO products, Precision Dogs, if I'm not mistaken. They have a couple different size dogs and a couple different precisions with the actual, the fine tuning of the size of this, so how tight that they fit into a hole. So these are the precise ones for 20mm dogs. Now in this case, it didn't really matter which one I chose because I'm making the hole to fit the dog, but they do offer these for like if you have like a Festool MFT, or maybe you have a tabletop that is similar to that. They use this 20mm dogs. There's a couple different precision sizes that you can get for whatever setup you have. Anyway, the whole point of these is this layout here is to replace the grid that I cut into the last setup. So in the last setup, I went by the grid. In this case, I'm going by the corners established with all of these dogs. So I know on the computer, because I still have the file that cut all these dogs, that if I line something up into a corner, and I move this over here, I line up my material up against that dog, I know on the computer space, just like with a grid cut into the spoil board, this exact corner location, and I can design from there based upon the size of the material that I'm working with. And if these are in the way or whatever and it's less precise stuff, I don't even necessarily have to use the dogs. I can line stuff up with the edge of the dog holes and let's say the center of the T-track, whatever. Anyway, I've got a lot of reference items here to go by to line stuff up very quickly and easily. So that's very handy with these dogs. But also the most important thing here is it allows for batch machining. So I designed, you can see one full column here. This is a group I'm going to call a column. So there's one column, 2, 3, and then 4 columns of dogs, groups of dogs. And this one over here on this side is basically a one-sided version of this, and this is just to have a far left locating for larger stuff like a tabletop or something like that. These columns are very handy for locating corners for batching out a ton of parts. So think about how powerful this is. If you're a small business, say you do a bunch of tables, let's just say you've got a job for 10 or so tables for a library. That's something in my head right now because I just saw that on Instagram. Somebody got a commissioned job for a bunch of tables for a library. Well, in this case, you can set up all of your table legs into these corners and batch out all of your mortises for your table aprons all at once. And basically, due to the size of this table and all of the corners that are established, you can cut a tremendous amount with one setup. So to clamp all this stuff down, first thing that comes to mind is you putting a bolt in between both of these, and then a bar that goes across, a piece of wood with some holes or slots cut in it to go down on these bolts, and then you secure them with a nut and washer on the top, so you can clamp down all of these at once, have them all precisely located so you know exactly where they are, and then cut all of them at once. That is very powerful to a small business. You can see where this can be very beneficial for a lot of larger jobs. And then of course, you still have the same one-sided setup if you want to space these out even further for, just doing 4. You take the same side on all of these, and it's the same setup on the computer. So that's why I went with these particular dog setups, this particular dog setup. And of course the T-track in between, because it's bolted down, you can clamp down on all these as tight as you want, and you're not gonna have to worry about the T-track coming back up. So with that, the spoil board is done. It is done, it is usable, and I've already actually been putting it to use just the way it sits right here, and I couldn't be happier with it. It works really, really well. Next on my list here is the vertical table, and to do this, a few modifications to the actual machine. These, I guess, yeah, you can see it a little bit. So these brackets right here, these black brackets, were up here on this top corner, and I moved them down just so I'd have a little bit more egress right here as far as if clamps were sticking out. Now that I look back and think about it, that was completely pointless because those don't affect anything at all. But I also added another interior frame piece. So one of these pieces, I added another one about 12, 13 inches in from this piece right here. So that new piece that I added is what the whole table is going to be mounted to. So my first mounting method did not work, and I'll explain in detail in just a minute. But my thought process was to cut out a piece of MDF to call that a mounting surface, right? So a mounting plate, I guess you could say. Once that was cut out and installed, I went ahead and cut out the entire vertical table, again using the same T-track and all of the dog holes. And then with all of the T-track installed, I had some bolts sticking out the back side, and I thought it would be very convenient to basically hang this table on top of those on those bolts, via those bolts. So those bolts would go into slots that was on the mounting plate, and it would kind of hang there. And from there, I would secure it loosely on both ends, and then use the Z-axis touch-off plate on each side to determine what side was high, what side was low. Once the high side was determined, I could put a flat bar or a flat, what is it called? It's a precision half-inch piece of carbide into the router, so it has a flat bottom, right? Into the spindle, has a flat bottom, and I could use that as Z0 to lift the low side up against the bottom of it and bolt it in place. At that point, the top surface of the vertical table should be exactly perpendicular to the Z-axis. Now, one thing that I forgot to mention before I got to this point is that first interior piece, that extra piece that I added, it was very important to make sure that was exactly parallel with the X-axis. So I got it really, really close by clamping something to the actual piece of the frame, and then using the corner finder on the Z-axis touch-off plate thingy, whatever the exact term is. And that gave me an exact location or an exact value for my Y at the front face of that new piece of the frame. And from there, I could go back and forth, left and right, to get the two values as close as possible. And if I look at my notes here, I think I took a picture of this as well. So it took me 3 tries going back and forth, but I finally got that interior web section to be 0.0029 inches from exactly parallel with the X-axis. So that's pretty darn close, and close enough for me. 3 thousandths of an inch, that's pretty close. So that is very important to get that as close as possible to the X-axis. And then back to how I mounted this the first time that didn't work out. Once I had the elevation set so that it was perfectly perpendicular to the Z-axis, then I had to either push in or pull out the bottom side of the vertical table so that it is exactly parallel, the front face is exactly parallel with the Z-axis. All right, I ran into a problem with the vertical table. My initial plan's not going to work. Let me explain why. So first off, I installed an extra web into the frame, and I have 2 more feet, and I thought it would be a lot easier to not use those feet, and I'm running into a problem now that would be solved if I used the feet to begin with. So I got to redo everything, redo all the mounting, install these feet, and then it should be all good. But let me explain why. So first, I've got a really long level. It's a 7-foot level with a nice square clamped to it, so I can check how vertical this is. And the problem I'm running into is it's fixed up here at the top, and my plan was to have it all pivot one way or the other up top and then secure it over here. So this can slide left or right, and there's a slot in this piece with some bolts going into this leg over here, as you can see on this side. Right? Slot, 2 bolts. This will move around. the problem is this isn't simply bending, or pivoting I should say at that point. Instead it is bending. So there's what I'm getting at is, in order for this to read somewhat level, this actually has a big hump in the middle of it by the bottom side flexing out. So it looks level up here, but then down to here there's a big gap. So this vertical table is flexing back. Now if that was simply bolted to this leg, then that would pretty much solve everything. It would eliminate the flex, and then it would just bend and pivot up here at the top. So that's what I got to do. This method of just screwing a leg on to stop it from dropping after I check the top for parallel with the table, and then clamp or screwing this on, that's not going to work. So all that has to come off. This table has to come, vertical table has to come off. All the screws in the back bolts, all that has to come off to be put back onto the table, so I can drill some precise countersunk holes here to go into the legs. The first mounting method did not work, so that was the end of one particular day. I spent the entire next day basically redoing things. I had to recut a couple holes for the T-track mounting bolts. So the far left and the far right T-track mounting bolts, all of them had to be moved in just a little bit, and also cut a couple slots on the ends for the new mounting hardware. And one very, very good benefit of all of these dog holes is I took the entire vertical table, took everything off of it, set it back in place on those dog holes, and I had a very, very precise way to recut whatever I needed to cut. So after all that, this is the result. So I don't know why I did not mount this the way I have it now in the first place. This is the way it should have been done in the first place. I was just trying to get around it because I knew it would be somewhat difficult the way I did it, and be easier to take a shortcut. Shortcut ended up being problematic, so I had to go back to the first method, which I should have done, like I said, in the first place. So I haven't made it perpendicular to the table yet. I'll do that in just a second, but I want to show you the change. So I added two legs, two more legs, one there, one here. They're just floating, not touching the ground just yet, and they bolt to the bottom of the new piece that I added to the frame. So this vertical table is mounted securely on this side and this side via the push-in bolts, push-in nuts and bolts on the front. The top isn't, because at the time when I switched this over, I couldn't think of a way to make that change. However, now that I see this all done, I'll have that in the final version of this in V-carve. So what else did we do? New brackets, and these have a slot and a counterboard slot, and then a slot on this face, and then also on the opposite face for that side. And that's going to lock in the distance in between these legs, which will determine how vertical this is, the vertical swing of the whole table. So I'm about to do that by putting a straight edge all the way across the work surface, and then a square going this way, and just lining it up perfectly, and then lock it into place once I get this established. Once it's established, then I'll also lower the feet to take the weight off of all of the mounting bolts. So let me show you how this is mounted. This design or version has some slots over here. There's 4 on either side with a little bit of left and right wiggle room. And this slot is to accept 5/16 carriage bolts. The carriage bolts are slid down into the leg before the legs are attached to the horizontal piece. And those carriage bolts, once you pull them out into the groove of the aluminum extrusion, they won't twist. So there's a washer and then a bolt for a 5/16 carriage bolt. There's 4 of those. So that's on either side. Now that same setup should have been done vertically right here to lock it into this frame piece that's over there. I didn't do that and didn't think about it until after it was done. So instead, when this is not something that I recommend, and I'll have it done the right way in the VCAR file, but I drilled some holes for some long washer head screws right into the aluminum extrusion and pinned it to the extrusion with those 2 screws. Not ideal, but this thing is permanently set, and if I ever have to change it out, well, it's just 2 screws right there. The best solution, like I said, would be 4 more. 1, 2, 3, 4. At the very least 2 of those slots. Now I need some right here because this was no longer attached to this, and I could wiggle this back and forth right in the middle, and of course the sides are pinned so that there's no wiggle on either end. But that's not good if this wiggles back and forth, because this is the primary reference point with all of the 5-degree increments all the way around. So now, ouch, I just walked into my camera. Now I got to put the level and square up here to pin this vertical. Let's talk about the vertical table and why and how I came up with this design. Before I do that, I can't show you the entire table at once because this bar is in the way. So this front rail is in the way. I position the camera so that it's blocking the least amount of important stuff. So it's between this first row of T-track up here and the second row right here. The only thing in between that is a pair of vertical dogs in a pair of dog holes in a vertical arrangement. So what all can this do? Well, I have 3 columns of dog hole arrangements so that you can mount up to 6 pieces perfectly vertical, referencing on either side of the dogs. So I've got this one right here, this 2x4 on the left-hand side of these dogs over here. You can do a left and a right, left and a right, left and a right over there, and have 6 at once. Now the middle one right here doubles as an angle setup, and I've got both a left and a right angle setup, and they're in 5-degree increments. So right about here where you can't see it, there's a dog hole and a dog just below this top row of T-track. Everything's based off of that one for the angles. So coming down here, that is a vertical position, so you can do left and right clamping once again. But everything out to the side of it is in 5-degree increments. So this right here, if you use this and the top one, that's a 5-degree angle. 10, 15, 20, 25, 30, 35, 40, 45, 50. And I did this in 2 different arch patterns so that there's a greater distance in between every single one of these holes, and therefore there's a lot more supportive material around it. Less likely for these to really wear out the holes as far as, you know, pushing if you're using a cam style clamp, which I typically wouldn't do. But these 2 just allow a little bit more room, these 2 arches. So you can do perpendicular cuts, you can do angled cuts. These slots down here at the bottom, that's for additional clamping. So if you need some more clamping force and I ran out of all the T-track style clamps, then I can use F-style clamps, and that'll really be beneficial. Now let's talk about a situation where all of this could work in harmony with one another. So let's just picture a basic project, a shaker style end table. You have 4 legs, 4 apron rails, and each one of those joints is a mortise and tenon joint. So there's 8 mortises, 8 tenons. In this case, if you are doing, let's just say 1 table, you can put all 4 of your legs up here on the horizontal table and then clamp 4 rails on either side of 2 of these vertical columns of dogs. And you can set your height of these vertical pieces with the same height as the top of these horizontal pieces. So that means your Z-axis, your Z position is the same for the entire job here. Clamp everything in place as it should be, and you can cut all 4 of your mortises on the legs and then all 4 of the adjacent tenons all at once. Then flip the legs around, so you cut the adjacent mortise, flip the tenon boards around, the rails around, so you cut the adjacent tenons, and with two runs of the same program, you can cut all 8 of your mortise and tenon joints pretty darn quick. So this continues the mindset of like batch operations, but in the vertical form. So cutting mortise and tenon joints. And then also, like, you know, the whole angled thing here is just really fascinating too, to make, say, like angled bridle joints for splayed legs. That's very common in, say, mid-century modern type of base legs. That basically covers all of the horizontal and all of the vertical table design, why I did what I did. The T-track is awesome. It's bolted down. It's not going anywhere no matter how hard I clamp something down, which is great. Also in the T-track is a bunch of notches cut out. So there's 3 internal notches and of course 1 on either side. So there's 5 different locations that you can actually insert a T-bolt throughout the whole 48-inch length of each one of the tracks. So that's really cool. The dogs allow for a lot of repeatability, repeat locating, and I've got a lot of them to set up batch operations, which is really fascinating, something that I really want to explore going in the future. And of course, the angled vertical table will cut precise angles, and I'm looking forward to using that as well. That's basically it for this video. In the next video, I will be covering the machine file, which is really important for an entire setup like this. And during that video, we'll actually be cutting some stuff on the vertical table to calibrate those points in digital space so that I have a digital location for a mounting corner that coincides with a physical location on the machine. All of that is basically a necessity for how all of this works in harmony with everything going on. So if you're interested in all of that, check out my website, jayscustomcreations.com/newsletter, and sign up for my email newsletter so you'll be notified of everything that I publish. I publish more stuff on my website than what makes it to this main YouTube channel. And also, if you're interested in all of the exact specifications for all of this, I'll have vector files as well as a VCarve file of this entire setup available on my website soon. Hopefully by the time that I get working on the machine file, the template file. I think that's it. You guys take care. Have a great day, and I'll talk to you in the next video. That was a horrible wave.